Hi guys, this is Dr. G here, and in this particular video we are going to talk about the preparation of ketones, or in other words, we will briefly talk about the synthesis of ketones using different reactions. By the way, at this level you should be familiar with almost all of these reactions. So if you want more details about these reactions, I would highly recommend going back and revisiting your lecture notes and also my previous lecture videos. Okay, so the first reaction we are going to talk about regarding the preparation of ketones is the oxidation of secondary alcohols. So in here, you are going to need a secondary alcohol. Okay, so let's draw a secondary alcohol. Okay, here is a secondary alcohol. All right, so for the oxidation of the secondary alcohol, you can use many different oxidizing agents. Okay, you can use multiple different oxidizing agents. Especially you can use Des-Martin periodinane. Okay, Des-Martin periodinane is one choice. So let's note that you can use DMP. Okay, Des-Martin periodinane, or you can use a powerful oxidizing agent like a chromate, dichromate, or maybe like chromium oxide. Okay, so you can use a powerful oxidizing agent. So regardless of what you're going to use as the oxidizing agent, you will get your ketone. Okay, you will get your ketone. So that is something important. Unlike aldehydes, when it comes to ketone oxidation, you can use multiple different oxidizing agents. Okay, multiple different oxidizing agents, and in here I'm going to use CrO3, chromium 6 oxide. Okay, and the alcohol group will be converted, the secondary alcohol group will be converted to a ketone, okay, that is how it happens. So you will take your secondary alcohol, always remember to use a secondary one. Okay, and then you will get your ketone. We have learned this reaction before, so this should be just a reminder for you. Okay, all right, so the second reaction that we are going to talk about is the ozonolysis of alkenes. Okay, ozonolysis of alkenes. So this reaction is also discussed in much more detail earlier. Okay, so for the ozonolysis reaction, you are going to use a reagent ozone. Okay, ozone as your reagent. Okay, so in here you are going to need an alkene, and the alkenes should be di-substituted. Okay, alkene carbons should be di-substituted. So let's use one such alkene. Let me change the color. All right, so I'm going to use an alkene like this. All right, so this is my alkene. Okay, and then I'm going to use ozone as my reagent, so O3. And then of course in the second step you are going to need zinc. Okay, so I hope that you guys remember the reagents. If not, if you don't remember these reactions properly, I recommend go back and watching the previous lecture videos on these reactions. Okay, so in ozonolysis what happens is that you are going to cut through the double bond. Okay, so this is a cleavage reaction. Okay, so you will cut through the double bond. Okay, and when that happens, what you have now is a molecule that is cut through in half. So this is one half, is the other half. Okay, so what you do in this reaction is that you are going to put an O to the double bond end. Okay, so it is like, you're putting a bandage to stop the bleeding. Okay, so you put an oxygen on the end that you just cut. Okay, so in this particular example, I took this alkene just to show you the significance between the substitutions on each alkene carbon or sp2 hybridized carbon. So if you have a di-substituted carbon like this one, okay, this carbon is di-substituted, the compound that you are going to get is a ketone. But if you use a monosubstituted carbon, okay, if you have a monosubstituted carbon, the compound that you are going to get is an aldehyde. Okay, so it is important to remember the significance in substitutions. Okay, substitutions that you have in the sp2 hybridized carbons. Okay, All right, so this is the second mechanism. Sorry, it's the second reaction that you could use to synthesize alkenes. And in the third reaction, we are going to talk about Friedel-Crafts acylation. Once again, this is a well discussed reaction from before. This is a well discussed reaction from before. In here, what you need is an aromatic compound, aromatic ring. So let's take benzene as an example. Let's take benzene as an example. Here is your benzene ring. And for the benzene ring, you are going to use an acyl group. So let's use something like this, CH3COCl. Okay, let's use this one. And then of course, as a catalyst, you will use aluminium chloride. Okay, LCl3. All right, so this is your catalyst. And then what happens is that you will attach the acyl group. You will attach the acyl group to the benzene ring. Okay, so this is the reaction that you learned. Okay, this is the reaction that you learned. All right, so last, of course, but not least, we have hydration of alkynes. Okay, in this reaction you are going to need an alkyne. Okay, it could be terminal or not, it doesn't really matter. Okay, so let's use the terminal one anyway, but it could be the alkyne group could be at the middle of the compound. That is perfectly fine. Okay, so in here I have selected a terminal one, and this hydration will be done using mercury 2 sulfate. Okay, so catalyst that you are going to use is HgSO4. Okay, that is your catalyst. And then of course you are going to need some acid. Okay, probably sulfuric acid. Okay, so this will basically hydrate the alkyne. Okay, alkyne. And this reaction will occur according to Markovnikov rule. Okay, so this reaction will occur according to Markovnikov rule. So basically regiochemistry happens according to Markovnikov rule. Okay, according to Markovnikov rule. So let me remind you what Markovnikov rule is. Okay, so basically according to Markovnikov rule, okay, we can treat hydrogens like money. Okay, so basically hydrogen prefers to go to the carbon with more money or more hydrogens, right? So basically rich gets richer. So in this hydration you will add hydrogens to the rich carbon, which is this carbon right here, and then poor carbon will get the oxygen. Okay, poor carbon will get the oxygen. So this is Markovnikov addition. And then it has 5 carbons, so 1 2 3 4 5, always count them. Okay, and then the poor carbon will get the oxygen and the rich carbon will get, this is the poor carbon, this is the rich carbon. Okay, but these are of course imaginary, don't put P and R everywhere, people will get confused. Okay, so excuse me. All right, so that is how it happens. It will be Markovnikov addition of water. So simply, I mean, for the people who tend to learn things graphically, what happens is that the rich carbon will get the 2 hydrogens from water, and then the poor carbon will get the oxygen from water. This is how it happens. Okay, this is how it happens. All right, guys, with that we are going to conclude the summary of reactions that you need to know for the preparation of preparation of ketones. Okay, ketones. And let me know if you have any questions. Okay, so you guys have a good one. Okay, take care.